Okay, domain is always a tricky topic. So let's take a look at a couple of the practice problems. Okay, this function is a polynomial, and therefore its domain is always negative infinity to infinity. This function is a rational function like the kind we were talking about today. We just have to guarantee that the denominator will not equal 0. So 2x minus 1 can't equal 0. So I guess x cannot equal 1/2. Now you should write that in interval notation, which means we are simply leaving out 1/2 from the domain. Any even root, so this is a square root, but this could be a fourth root or any even root, you have to guarantee that the inside stuff is greater than or equal to 0. So that means greater than or equal to -4. So interval notation, -4 to infinity. This time, however, I have a radical or an even root in a denominator, which means it can't equal 0. So I have to make x plus 1 this time just be greater than 0. So that's -1 to infinity. Okay, here we have 3 different denominators. I have to make them all not equal to 0. So this is going to be a little crazy. I will have x can't equal 0, -1, or -2. So my interval, it's a big long union. So I don't include -2. I don't include -1. And I don't include 0. So picture this as the whole number line, but with like an open circle at each one of those locations. Okay, last one. Again, a rational function. I have to make sure my denominator does not equal 0. So they didn't factor it for me, so I guess I'm going to have to factor it myself. So here's the 6x. I need that to be negative. And then a positive 1x. So I'm pretty sure these are my factors. So I'm going to say 2x plus 1 can't equal 0. And I'm going to say x minus 3 can't equal 0. So I'm going to leave out on my number line, I will leave out -1/2. Running out of room. And 3 to infinity. Okay, so look what I'm leaving out -1/2. That's a negative on there. And I'm leaving out 3. Voila!